Okay, now this problem, we have to prove a few statements. Let's start with the first one. The sum of convex function is convex. It suffices to prove that the sum of two functions, two convex functions, is convex, and then by induction, you can um, make the argument that it's true for any sum of any number of k functions that are convex. So first, let's start with the definition of convex. We have seen many. The one we will use here is the following. F is convex if for all, so this is a fancy math way of saying for all or for any, W, W prime, oops, in RD, vectors in RD, and alpha belongs to 0, 1 inclusive, then we have this following statements that hold. F of alpha W plus 1 minus alpha W prime smaller than or equal to this. So this is the definition of convexity we're going to use. You can see other definitions that say, let's say, for example, a figure is convex if any line segment drawn between 2 points of the figure lie inside the figure. Example of a non-convex figure is this, because you can draw a line between 2 points and it doesn't lie inside the figure. But we're not going to use this definition now. We're going to use this one. And okay, great. We have the definition of convex functions. So now let's say let f and g be convex functions. And again, I'm not going to write the whole proof in detail because it's going to take a while, like a presentable proof. I just want to make this video short and give the intuitions, but I'll keep a fair amount of detail. So f and g are convex functions, i.e., we have two equations that hold, or inequalities, let's say. This and then this, right? And then all we have to do is just replace f here with g. Right? And we can call these equations 1, 2 if you want to be fancy. Doesn't matter. Sorry, 2. And now we want the sum of these two functions. So let's add the two equations. Let's add 1, 2 and see where that gets us. So 1 plus 2. Where do we go? Since I'm lazy, I'm just going to duplicate stuff. This, since they're both inequalities, you can, it's closed under addition, right? You can add two sides of an inequality and it stays an inequality. Okay, so this is what we have now. And then notice that if we define H is equal to F plus G, then this, okay, wait, define this, and then this is equal to, wait, maybe before this step, let's do something else. The inequality above implies that this is true. And then here we can factor by the alphas and the 1 minus alphas, right? Think of them as weights, if you will. 1 minus alpha f of w prime plus g of w prime, right? And this is starting to look a bit promising, right? We have a sum here, a sum there, and a sum here. So this is basically now the step we wanted to do earlier. This is basically if we define, let's define it here. This is basically h of alpha w plus 1 minus alpha w prime smaller than or equal to, and this term, this part of the inequality is also alpha h of w plus 1 minus alpha h of w prime, right? And so this means that h is convex. H, which is the sum of the two convex function, is convex. So here, this would be, you can repeat this infinitely for however many sums of function you want. So therefore, you can prove that any sum of convex functions, the sum of convex functions is convex. And in math, when you want to finish a proof, it's nice to put a square here to indicate that your proof is done. So yeah, that's the proof.